So I'm going to take a little bit of a different approach today with these notes because there's so much writing on these notes. You don't need to sit here and watch me write. We're going to talk about how our postulates that we're going to be learning today relate to this figure and how we can find examples in this figure. We're going to talk about some theorems, also related to points, lines, and planes, and we'll do a couple of exercises. I will put a key for this online, so if you can't follow what I'm saying enough to write down some notes, then you can go and get the key online in my locker. And bear in mind that the postulates and theorems are available on a comprehensive sheet that numbers them in the same way your textbook does. And I'm providing that in class, but it's also in the locker, in the geometry folder, and in the task 3 folder. Your teachers should have copies as well. Okay, so we've already discussed what a postulate is, and I've also explained to you that generally postulates are common sense. So let's take a look at postulate 5. A line contains at least 2 points. Okay, so let's just take that piece of postulate 5 and go down here to our drawing. A line contains at least 2 points. So there is a line N in our drawing, and it does have points A and B on it, so it does contain at least 2 points, namely A and B. Okay, so there's our example. That's all we're doing with these. We're going through and finding examples in our drawing. Okay, a plane contains at least 3 points, not all in one line. Okay, so here's a plane P, and it contains B and A and also C, and they are non-collinear. So in fact, plane P does contain at least 3 points, and they are not all in one line. We're not going to address the last piece of that space contains at least 4 points, not all in one plane, but I'd like you to think about that one. It's not addressed by our drawing. Postulate 6, through any 2 points there is exactly one line. Well, let's look at our 2 points, A and B. There is indeed a line that goes through them, and there is only one line, and it is N. One and only one line is the same thing as exactly one line. Okay, let's look at postulate 7. Through any 3 points, there is at least one plane. Okay, so here are 3 points, A, B, and C, and indeed there is one plane that goes through those 3 points, and that is plane P. Through any 3 non-collinear points, there is exactly one plane. So P then would be the one and only one plane that goes through A, B, and C. Now, something I'd like you to think about is, what if we had a point D over here on line N, so we had D, A, and B that were collinear. How many planes could go through those 3 points? That's something for you to think about, and ask me if you're not sure of the answer. Okay, it's more than one, I'll tell you that. Okay, now postulate 8, if 2 points are in a plane, then the line that contains the points is in that plane. So here are 2 points in plane P, and the line N that contains those 2 points is in plane P. So that provides our example. Okay, if 2 planes intersect, their intersection is a line. Well, P and Q intersect, and so they intersect in a line, and that line is M in this situation. Okay, now we're going to look at theorems. A theorem is a statement that is proved, and it is generally quite an important statement, and again, you have a list of your theorems. Our very first theorem actually is not always defined as a theorem. Some textbooks, consider it a postulate, and it's very similar to postulate 9 that says if 2 planes intersect, their intersection is a line. Well, theorem 1.1 says if 2 lines intersect, then they intersect in exactly 1 point. In our book, this is a theorem. And let's look at our drawing, which didn't print very well, so I drew in the dotted lines. and see if we can find an example here. So if two lines intersect, well, we have N and we have M. Those are two lines, and they do intersect in a point, and that point happens to be A. So there's our example. Okay, theorem 1, 2 says that through a line and a point not on the line, in the line, okay, so here's a line and here's a point not in the line, there is exactly one plane. Well, that's the case here. There is exactly one plane that goes through this line and this point. One and only one. Remember that one and only one and exactly are the same thing. Okay, if two lines intersect, this is theorem 1.3, then exactly one plane contains the lines. Okay, so we have N and M. Those are our two lines. They do intersect. And can you see which plane contains them? Plane P contains them. Exactly one plane. One and only one. So those are our theorems. Now, what are we asked to do with these? Lots of things. One, we use them as building blocks to prove other things. But we also let them guide us in our reasoning about lines and points and planes and so on. And so let's look at a few statements and decide whether they're true or false. A line contains only one point. Well, if it contained only one point, it would just be a point. That is false. A line right here. Here's a line that contains more than one point. Okay. And if you want to pause while I'm reading these and then come back and check your answers, that would be a good idea. 3 collinear points are contained in at least one plane. So, 3 collinear points. So this goes along with what I asked earlier. So if you have D, E, and F, so they're collinear, they lie on a line. Well, certainly the plane that the paper represents, that they're written on, contains those 3 points. But is there another plane that contains those 3 points? How about one that if I were to take a piece of paper and cut straight through this way and that represented a plane? I'm not sure if you can tell, my pencil's moving up and down, so vertically. And you can imagine we could go at it from different angles. So three collinear points are indeed contained in at least one plane. Okay, 2 planes intersect in exactly one point. Actually, 2 planes intersect in a line, so that is false. Okay, 3 points, A, B, and C, are non-collinear. Non-collinear. A, B, and C. And 2 planes, M and N, each contain points A, B, and C. Actually, the plane that contains points A, B, and C is unique. There's one and only one. So that can't be true, so that is false. There is just one. It has to be M or N if one of them does. Okay, 2 points, P and Q, are collinear, and 2 different lines each pass through points P and Q. Here's P, here's Q. Could 2 different lines pass through P and Q? The line that passes through P and Q there is one and only one line. There is exactly one line that passes through P and Q, so it can't be 2 different lines. It could be lines that could be named different things if all the points R, S, X, and Y are on that line, but